Hi, welcome. I'd like to address LeetCode code number 1839, longest substring of all vowels in order. This problem essentially proposes a classification of substrings that it's calling beautiful. And a substring is beautiful if basically two constraints are met. The first is that all vowels are essentially contained in a substring of an even larger string. And also those vowels actually have to be in alphabetical order. So it's sort of a two-step process for verification. All vowels must be present, right? But that isn't to say that they must all strictly be of the same frequency, right? I mean, we could have a beautiful string where there are multiple vowels, as long as as long as the substring has all vowels present, regardless of how many times they're duplicated. And in addition to that, as long as they're in alphabetical order, then that is a candidate for that is a beautiful substring. But what we want to do is we want to find out, okay, well, we have this classification, right, of being beautiful, right? All the vowels must be there, and it must be in alphabetical order. But the idea here is that we want to return the length of the maximum, or we want to return basically the greatest length of one of these beautiful substrings, right? So of all the beautiful substrings that there are, which one has the greatest length, or the highest length, or the longest length, and then we would aim to return that. And so this is kind of what we have here. So the approach is to actually use I mean, of course, you could generate all, sort of a brute force ways to really generate all substrings. And then to go like maybe make these a helper method, right? One helper method could verify if all vowels are contained. One helper method could verify if all vowels are contained, and the other could verify if it's sorted. And then, of course, you could record the length. But this seems to be a taxing problem because you're generating all possible substrings, right? So it's not necessarily optimal to do that. I think that would either be quadratic or cubic in terms of time complexity. And so we usually revert to sliding window in those types of cases. And so the idea here is actually to have a pointer, int r and int l, right and left, or you could have end and start, right? I mean, that's also a popular one. And the idea is to actually leverage a set data structure. And we are going to move across the string and essentially add characters to the set. Now, why I say it's important to add characters to the set is because this set will allow us to keep track of whether or not at least one occurrence of the vowel is present in the substring. Okay, so I mean, we have to have some way to sort of assure that at least one of every vowel is present. And so the idea is if we add each of these vowels into the set as we move along, and they're all vowels, by the way, we don't have to verify whether or not it's a vowel. They're all vowels, and I think that's made very clear with the question, is that the word consists of A, E, I, or U. So they're all vowels, right? Verifying it isn't really the problem. The real problem is simply verifying whether or not two things, right? Whether or not all vowels are contained and whether or not all vowels are in alphabetical order. And so what we do is we move forward and we constantly add each character one at a time into the set. And then as soon as the set size hits 5, we will know that we have all five vowels in the set, because a set will only store unique entries. It's not going to store duplicates. So if I look at this string here, I have multiple A's, I have one E, I have 4 I's, I have 1 O and 3 U's, it will only store A, E, I, O, U. So as soon as that set size hits 5, I will know that there are at least one entry of of each vowel in this particular substring. And that's what helps. And as soon as I know that there are at least 5, right, or as soon as I know the set size is 5, well, then I can record the maximum, right? I can try to judge what the length is of that particular substring, which gave me a set that had 5 entries in it. And then I'll record its length and I'll compare that to the length I had before. And then I'll kind of go that way. Now, there's also one other part to this problem that I think I'll address after it's coded. So as I said, I'm going to have a set of characters here. I'll call it set equals new hash set. And the basic idea here is we are going to have our left and right pointer. And while that right pointer is, and I'm actually going to introduce another string here called s, so that I can have a more concise way of referring to word. I don't want to have to type out word too many times. So here instead of saying word.length, I'm just saying s.length, so it's more compact. So while r is not essentially, so if you say r is less than s.length and you keep incrementing r, it allows you to touch every single element within the array, or not the array, but really the string. And so r would actually have to be incremented, right, eventually, for us to get the algorithm to move along the string. And the idea is, like I said before, we'll say, okay, well, set.add the character that r is currently referring to, right? And we know that if the set.size is ever 5, then we can increment a counter, right? So int count is equal to 0. We can increment a counter because the counter, like we have a string where all vowels are present, right? That's why the set is 5, right? So we were adding them into the set as they came, and then the set being 5 meant that at least one entry in the set, or at least one vowel of every vowel was present in the set, and so we increment count by 1. But it actually, you know what, on second thought, it doesn't make sense to increment count because we're actually not counting the substrings that have this property. Instead, we're actually recording the maximum length. So I'm going to set the max equal to 0, and I'm just going to say, okay, well, max is either going to be what the max was before or the length of the current substring, right? So the length of the current substring, whenever you find the length just in everyday life, you always take the upper bound and you subtract off the lower bound, and the difference is the length. And that's true even for our case, right? We take the right one, which is obviously going to hold a greater value. We subtract off the left one, and then and that should give us the length. But the problem is these indices are offset by 1, so they actually start from 0. And them starting from 0 means that we have to have take that into account, and so we add 1 to it. So if I had indices 0 through 4, this would give me, 4, right? And then I'd add 1. And so the length of that would be 5. And that makes sense because an indice of 0 through 4 does have a length of 5. 0, 1, 2, 3, 4, 5, right? So the length of this is 5, but the maximum indice is actually 4, right? So basic idea, iterate through, add each entry into the set. If the set has ever reached 5, then we know that at least one vowel of every vowel is within the substring in question, which means we should probably record the length and see how it pairs up against the length we had before. And so that works. And then of course we increment right by 1, and then we return, we would basically return what the maximum was, right? Now, that's all fine in the way that it works, but who's to say that, like, how do we address, I mean, in essence, we've addressed this concern that, they must appear at least once. And so if I were to return this now, it would give me basically the maximum of a substring within which each vowel returns at least or appears at least once. But I want an even more carved out definition. of these substrings. I also want them to be in alphabetical order. So how do I filter that out? How do I filter it being in alphabetical order? Well, what you can do is you can say, okay, well, it being in alphabetical order, right? I mean, these are fine, right? A. But let's take a look at where this takes a turn, right? So you have A and you have E. This is, in fact, in alphabetical order, but what is some property that encapsulates this relationship of it being in alphabetical order? And you could say, well, perhaps it's the ASCII value, right? Because the ASCII value for letters that get larger are greater. So A is going to have a lesser ASCII value than E. So basically, if I say s dot caret r, right, this would have to be greater than s dot caret r minus 1, right? So when I say s dot caret r, it's returning to me a character. But in Java, I can actually also compare their ASCII values using these logical operators. So if I say s dot caret r, it would definitely be less than, or it would definitely be greater than s dot caret r minus 1. And a good way to demonstrate this is if we have a word, right, like A, B, C, D, E, F, if we say word.caret 1, so that's B, right? Is that less than word.caret 2, which is C? And this gets printed out. Didn't know that was possible, gets printed out because it is in fact the case that the ASCII value of C is greater than the ASCII value of B. And so in the same way, we can leverage that here, right? So we can say, well, if s dot caret r is greater, so it must be this way, right? It must be this way, but we can say if s dot caret r is less than s dot caret r minus 1, then what do we do? Well, it would make sense to start a new window, right? So we're gonna start a new window. So what I mean by that is, okay, so we're here, and then we're moving up and everything is fine, right? We're moving up and everything is fine. And I think eventually A, E, I, O, U. This basic substring contains every single character, but they're not in alphabetical order. So basically, we eliminate strings while we move that don't or that are not in alphabetical order. So as soon as we figure that out, we disregard that string and we reinitialize. Like we move L, which would be pointing at the end. We move L up to R. That gives us a new starting point. But then we also reinitialize the set. So starting a new window would just mean that, okay, well, that left pointer L is going to point to R, and we're going to do set.clear, which would allow us to start a new set. Now, one glaring problem here is on the first iteration, if you do s.caret r, which is 0 in the first iteration, and then s.caret r minus 1, which would be, you're referencing an index which is 0 minus 1, you're referencing minus 1. So that is an edge case here. That wouldn't make sense. And so really what you can do is you can say, okay, well, while r, or if r is greater than 0, now why I say r is greater than 0, that means it will instantly be added to the set. And that's actually okay because one letter in its own self is in alphabetical order, right? So it's okay. I don't need to make this judgment for the first character. So it's fine. And there you go.